we have now this nice little calculator, but I can only add things. Usually you would have a plus minus button. So how would you add this here? So I'm just going to add another line below my 1 and 2. If you click on the canvas, you see the corresponding code highlighted. So I would here add 2 more buttons. So one would say plus, and the other one would be minus. So we are going to make a very simple calculator. So now, how would we add this plus and minus now? And where would we store it? So similar to our operation steps array, where right now I only had here ints. How would I store plus and minus? This very specific cases of operations. And one very nice feature of Swift are enums, because they help us to be type safe. I could state var operations and store this here as a array of strings. Oops, like plus and minus. But this is, I always would need to remember what the correct writing here, what the correct spelling is, and it would never give me the spelling correction or errors if I didn't use the right string value. So you wouldn't probably, it's not ideal. Also, I don't get autocompletion. I like autocompletion, don't like to type too much. So instead of strings, if you have specific cases and you have strings, then it's a good idea to use a enum. So I'm typing here an enum, and you see I can choose a name. This is my math operation, and an enum has always cases, so I would have here addition, and we had now the other one, which was subtraction. So in this case, my operations array, I could now say this is not an array of strings. I can use this as the enum as a type. So I have here an array of my math operations. In the beginning, I have an empty one. So since when I press then the plus button, I would say that my operations, I can do the same. I can append a new element. And you see here append new element, and it gives me already the right type. So I have here a math operation. And how do I say which value? Because I only have specific cases. So in this case, I say dot, and you see here the two cases that are defined in my enum. It's addition and subtraction. So this is in this case. And in my minus case, I use here a subtraction. The nice thing is, because Swift is type safe, and we have already seen the cases of these type inference, so it already knows what type it is, you don't need to say math operation dot. You can just say append subtraction, dot subtraction. Let's just have a look at a couple of cases where we see enums. And the first one is this VStack. If you have a VStack, and just open parentheses, and you see here the horizontal alignment, the alignment parameter that I can define. So I'm just going to show alignment. And now you saw that we have a horizontal alignment type dot, and a VStack stacks elements like so, below each other. So you have the possibility to place them all underneath each other nicely, or you line them to the leading or trailing edge. So this is the 3 cases that the VStack can align the elements it wants to display. And you see here per default, the default value is center. So if I change this to leading, we should see something changed in our UI. So now you saw everything aligns to the leading side. And I can change this again back to the default value, which was the center. And because we saw that similar to here my math operation, my own enum, this horizontal enum, this horizontal alignment enum, the alignment parameter already expects this enum type. So I don't need to say horizontal alignment, I can just say dot center. There's another situation where you have this dot notation. So for example, my title, I want to have a different font. So after the text, I add here a font, and it asks here for a font type. When I press enter, it automatically gives me this title. If I now go to the jump to definition, so you see here that I have my font type, and we see here, so this is an extension which basically extends our font struct further. And you see here we have this public static let. So this is a static property, and static properties basically means it is a property that I don't need to use on the instance of my font. I use it on the class or on the struct directly. So what I mean by this, just go back. Here we call font, what we actually here call is font.title. And otherwise, before, some of these functions, like this operation steps dot remove last, this is a function I call on an instance of my array. I already have an array created and I'm going to manipulate it. So this one is called when I have an instance of an array, and this font dot title is called on the class itself or on the struct itself. And we have quite a lot of these static properties that we can use. So we have it for fonts. We also have it here for foreground color. So blue here is here you see a static let blue color. This is just a constant, a default value for blue color that is provided for us. Maybe I definitely shouldn't use blue here. Okay, going back to our little enum here that we created. So now we have here the possibility to save. Actually, this is not operation step. This is just the numbers we used so far. And we have the operations. So we have these two different storage that I would preferably have together. But since they are different types, it's not the really good idea right now. So how can we maybe extend our little math operations here a little bit more, so we can also use this one for numbers? So you can declare here another case where we would just say we have a number, but I need to actually store a number, and we can use here associated values, and this is a int. Now I'm going to use the math operations for everything. So we are not relying on the operation steps anymore. So the first thing is, let's have a look where we actually use the operation steps. Whenever the user clicks on one of my number buttons here, I want to say I add this number. So I'm not doing this with my operation steps anymore. I'm going to use this with my math, with my operations now. Maybe I should have called them a little bit differently. So I can again add here the operation. And in this case, I want to add a number. In this case, I have a number case. In the case of a number, because I use this associated value, so the value that belongs to this number case, I can add here my number. So now I can always add in my array node numbers, but I also need to store the plus and minus. So we did this here in these plus operations. So I already did this in my plus and minus operations. So now I have an array of either numbers, add or delete. But the thing is, actually I forgot, maybe I should, what happens if I click twice on the same number? Shouldn't that be together a number, not an extra number? So we need to do a little bit more operation here with our appending. So I would now, before I add this number, I need to check if the last one was operation or not. So my operations dot last. And this is again a optional one, so we're going to fix this with if let last operation is equal to my last, because we have to deal with this optional. So if I have a last one, I want to check what the operation actually was. So I would no need to, I could now write a if I'm in the number case, if I'm in the additional case. But if you have enums, we can actually use a switch case switch statement. So this is just an easier way of writing if my case is equal blah blah blah. It's just easier to write. So if my last operation is now here because it knows, can just say addition. And also if I have here a subtraction, then I can just directly do what I already said here. I just add the number as the new one. And then I have the other case is a number, that number value, because I need to know what the value was. I need to change my last operation's value, and because, just need to go up again, when I declared this case, this one, this value is immutable. I cannot change this. So how do I fix this? I need to create a whole new math operation and replace with this new number and replace this with the last operation in my array. So I'm going to say let new is a math operation dot number. So in here I need to say, how do I calculate this? This is my number value, so this is the old one I had, times 10 plus my number that I'm adding here. Because if I have here 1, then I press 2, that means that this one is a 10, and this is, so it's a 12. And if I add another one, I have 12 and I want to add another one, then it becomes 121, for example. So that's why I have to have here this multiplication with 10. Okay, now I have this new operation, and I need to put this value to the last operation value. So my operations dot. So I need to remove the last value, and then I'm going to append my new value. So I need to replace this. So you saw here, if I have an enum, I can nicely use this case to say, in this case, if the last one was addition or subtraction, then I'm clearly having a new number, so I just add a new number to my array. And otherwise, my last one must have been a number, so I need to change the number value. And I cannot change the number value in these cases. I need to create a whole new math operation value and replace this in my operation array. So what we did now is we moved all the operations, all the actions that we did to this new operations enum array. And the next thing is we need to change the way we calculate the display values. So, and the ones that we used for display is our final operation result and our operation description. So when we do our final results here, we are not using the operation steps. We're going to iterate through this operations array. So for oper and operation. So now I'm going to check what is actually in this operation. And I also, if it's a number, I need to also know if I need to add it or subtract it. This depends on what was before. So I'm going to store the before operation value. So this is bar operation action. Probably should have called this differently. And in this case, I'm going to use a optional value. This is a math operation, optional. So this is how you declare it with a question mark. And I'm setting it to nil. So in the beginning, I don't have any operation. I don't have a plus or minus. So now when I go for my for loop here, I can say, check what operation I have. So switch case, if I have a addition or a subtraction, then I'm using here this storage of operation action. Operation action. I'm going to set this to the one that I had here, which can be either addition or subtraction. And otherwise, in case I have a number, let number. Now I have a number, but in this case, if I have a number, I need to check what was in the last operation, math operation. So I can, which I use this temporary storage of operation action. So I can say if my operation action is equal to addition, then I can say results plus equal my number. Else if, so this is the other case when my operation, the last operation action that I stored was subtraction, then I use results minus equal number. And else, this is the case, this is the reason why I actually used here null. The first number I don't have an operation before. And in this case, I'm just going to add here my number. So the next thing it's complaining is this doesn't conform to Equatable. And I did here create my own enum, and I'm trying to use a function that inside of Swift requires the system to understand a little bit about my enum, because it doesn't know how to compare or how to equate my special type. And one thing that helped that we use in order to make it more system easier are protocols, and Equatable is one of them. So I can say, okay, I want to be Equatable. So now, because it has here these 3 different cases, it automatically can make this Equatable. Sometimes if the system asks you, yeah, I cannot do this because this and this, you didn't say I actually can do it, then it will require you to add a little bit more information here. And we'll see this kind of examples more in detail later. Okay, now I did write a lot of if, else, switch cases, but you see this kind of enums can make my life a lot easier once I understand how to use them, because I can now deal with all these different cases. So let's see if at least our final results now works. So I add here a 1. Oops. And I seem to have done something wrong, but I only see my final results. Let's now have a look at our operation description. So as before, I'm not going to use my operation steps, but my operation enum. So here you saw we had to deal with this plus or something, but actually it's much easier because now I have here an operation that can be either a number, then I would just use the number directly, or a plus or minus. I just need to know what kind of string values to use. So I'm going to delete this here. So I have now here these operations, and I would like to have just a function, just the string value for this operation. And it would be actually nice to have an operation and just call, yeah, give me your description. So we're going to create a function in our enum, which we call description. So this function, when we call it, doesn't need to have any input variables, but it should return a string value that we can use to display. So we're going to use a switch case again, and we are using this on ourselves because we created this function in this enum. So in case of addition, I'm going to return here a plus, and maybe with some spacing in between. Then I have a case.subtraction where I return a minus, and I have a case of case.number, let number. And in this case, I'm returning here, and I'm using here my number. So now I have this nice little helper function that I can call on all of my instances that I used with this math operation. So in my calculator view, and we are going to build our whole description of this calculation, I can say results.append a new string value, and get this from my operations description. And we should take out this enumerated here. Too much changes. Okay. So you see, this made it really nicely readable in my main code. Add to my results the operations description with string value. So I can now press here. Yeah, it seems I have a problem. If I press here 1, you see it appears in my string, and now I can add here a lot of numbers and then plus. But the first one didn't work. So if I clear everything, this also doesn't work. My clear doesn't work because I still use the old operation step. I'm here using my operations. And whilst I'm at it, in order to make sure that I really don't use these operation steps anymore, I'm commenting this out. Because wherever I use it will give me an error, which it does. Okay, so when I have my back button, I'm also going to say my operations. So if I have actually something in my operations array, then I remove the last one. So now I have my interface. I can here It seems I cannot add a number in the beginning because I did something strange here. Yes, sorry. You saw here that when I add my number, I only took care of the case where it had some operations. So I'm going to add here else. I'm going to say if I don't have a last operation, which means I start with an empty array, this is not a problem. I'm just going to append a new value and I create a number and give here the number. So now if I start, I can press a 1 plus 2 minus 1 plus 12. And I can delete the last one, which is my 12. So now we used quite heavily these enums and created our own enum here. They can be very useful to work with. Now you saw a lot of the Swift programming language where we went through some of the types like ints, bools, some special things like optional values, and the for loops, switch cases, if-let statements. Then we had here how to declare our own functions with different input values and return values, how to work with arrays or collections of things. And we even had a look at our own enum. But right now we have reached quite a good point, actually covered quite a lot of ground. And our little calculator works quite nicely.